Hello everyone. In this video, I will be demonstrating my solution for task 3.2p full AP implementation. The objective of this task is to upgrade the robot simulator backend into a full .NET Core Web API using controllers instead of the minimal API approach used in task 2.1p. The new system architecture follows an entire architecture which separates different parts of the application such as controllers, models, and services. The structure improves modularity and allows the system to be easily extended in the future. The system includes two main bounding concepts: robot commands and maps. Each context has its own entity class, controller, API endpoints. For the robot commands context, the API supports operations such as retrieving all commands, retrieving move command, getting a command by ID, creating new commands, updating command, and deleting a command. For the map context, the API allows managing maps, retrieving scarce maps, checking coordinates inside the map. Finally, the API must be tested using Postman to demonstrate that all endpoints work correctly. Now, for this task, I followed a structured backend design approach. First, I created a new core web API project using the command .NET new web API. This created the base project structure with controllers and routing spool. Next, I identified the two main contexts, robot commands. Then I created components. For robot commands, robot command.cs and other is robot command controller.cs, controller with endpoints. Similarly for maps, map.cs the entity class and map controller.cs controller with endpoints. Inside each controller, I implement endpoints using attribute-based routing, which map HTTP requests to specific methods. For example, HTTP GET, HTTP PUT. To keep prototype simple, I used in-memory list to store commands and map instead of database. Finally, I used Postman to create a collection of endpoints and execute them using runner to verify the API works correctly. Now, moving for the code. Robot command entity. The robot command class represents a command that can control the robot. It contains the following properties: ID, name, description, is move command, create date, modify date. These properties allow the system to store information about robot commands and track when they are created or modified. Now, moving to the robot command controller, these handle all the robot command endpoints. A private list stores existing commands such as left, right, move, place, report. For example, HTTP GET, return commands. This will endpoint returns all available commands. Now get move command. So this endpoint filters the command list, returns only commands where isMove command is true. Now other is the getting the robot command by ID. This endpoint retrieves a specific command. If the command does not exist, the API returns 404 not found. Then we have HTTP post methods. This create allows the user to create a new command. Commands cannot be null. Commands must be unique. The date of creation and modify are set automatically. It will return 201 status code of creation. Now we have the put update command using ID. Here ID means we have to must put IP in the endpoint. The endpoint modifies an existing commands. If command exists, it updates and returns 204 no content. Now moving to the delete command. This endpoint removes a command from the collection. Now moving to the map entity. This map class represents the grid where the robot operates. It includes properties such as ID, columns, rows, name, description, create date, and modify date. And similarly, the map controller provides endpoints to manage maps and check whether a coordinate belongs to the map or not. Now let's test our system. Now it is successfully working. Now let's try the commands. We have to also put API in this robot commands. Here we have get all the robot commands we have: left, right, move, place, and report. Now testing the other command, move. Here we have get all the commands with move that will move our system. Now searching it using the ID. Here when I put the ID 1, I will get the first ID with first ID of robot commands. If I enter an invalid ID, I get an 404 not found error. Now let's try to create a new command. Post Singhara. Suppose we put back is move command. Suppose initially we put it false. Now let's send this. We get a 201 created with ID 6, and the created date and modified date is set automatically. Now if I send this post again, I will get 409 conflict because it already exists. Now try with an update command. Put, suppose we are updating our first command. Its name is, initially it is left. Now let's set left updated and set this move command to true. Enter. No, send. 204, no content. So it is updated successfully. You can check it through robot commands. Oh, sorry, it has to change the method get. Here the left is updated, and you can also see our new command which we have added. Now test the map APIs we have. So these are the name Moon, Deccan, Burwood. These are all we have set in our code. Now try to finish post a map. For example, name, as it is string, we have to put in inverted commas. Let its rows be 10, and let's column 0, 10. Now let's try this post command. We get a 409 conflict. Now let's try other commands. Get map through coordinate. Map, suppose we have first and its coordinate is 3 comma 4. We get true as it is a valid coordinate. If we put an invalid coordinates, we get false, 404. To conclude, this task successfully implements our system. The system include controllers for robot commands and maps. So thank you.